This video will cover internal validity, types of biases, and measurement properties. Remember from the last video that internal validity is the degree to which a study results are true for the groups being studied. Or, in a relationship study, internal validity can be thought of as the degree to which the relationship between the independent and dependent variable is free from the effects of extraneous factors. In a change study, internal validity can be thought of as the degree to which the change in an outcome, or the dependent variable, can be attributed to the intervention or independent variable, rather than extraneous factors. Remember that bias is a systematic error that results in deviation from the truth and threatens internal validity of a study. Confounding bias is a contaminating effect of an extraneous variable, usually a confounding variable, on the interpretation of the relationship between independent and dependent variables. Remember that a confounding variable is associated with both the independent and dependent variables. In this case, what happens is the effect of that one variable is confused with the other. The distortion is brought about because it's associated with both factors. Another type of bias that can be present is called a selection bias, and this occurs when participants are selected for a study, but they differ on a factor that influences the outcome. Remember that these are reduced by random sampling methods, but not necessarily eliminated. Let's talk about the different types of selection biases. An assembly bias, also called an assignment or allocation bias, occurs when the study groups are different at the start of the study on an important factor. In short, the groups were different and assembled with this difference to start with, and that difference may affect the results. For example, if there's a 10-year difference in mean age of participants between two groups, and the younger group does better on the outcome of interest, let's say walking speed, it may be due to the age of the participants and not the intervention. Frequently, this bias is due to a poor method of assigning people to groups and can be easily recognized by carefully examining your Table 1. A history bias can occur when an outside event or corresponding effect occurs during the study that is unrelated to the project but may influence the results. This often happens when a group is observed or treated at a time and then compared to a group that was representative of the past, or vice versa. As an example, let's say an investigator is comparing severity of injuries sustained in car accidents over time to show that reducing speed limits saves lives. So they compare data that was collected in the 1970s, where speed limits were 80 kilometers per hour, to data from the same road in the 1990s, when the speed limit was reduced to 60 kilometers per hour. However, a targeted ad campaign was released in the 1980s regarding effectiveness of seatbelt use in reducing catastrophic injuries from car accidents. That ad campaign influences the dependent variable for only one group, the 1990 data. A maturation bias can be present when changes occur in the dependent variable as a result of the natural process of change that occurs with the passing of time. For example, growth and development of children or recovery from injury. A regression bias can result when the dependent variable is known to experience fluctuations in values. If a variable fluctuates and you take measurements that are at different times or during different points in the fluctuation cycles, any change in the variable may really just represent the normal oscillation around the average value and may not be due to the effect of the independent variable. This is very common with biological or physiological variables such as heart rate or blood pressure. A migration bias, also sometimes called a contamination bias, happens when subjects switch groups in a pattern that influences the outcome. For example, if a control subject in a study about exercise decides to start exercising while the study is going. Finally, an attrition bias, or sometimes called withdrawal, dropout, or mortality bias, happens when subjects drop out of groups within a research study in a pattern that influences the outcome. For example, in an exercise study, when the exercise is too intense for participants with more severe presentations of a condition, they don't continue with the study or they miss sessions and influence the final results of the study. Another category of biases is related to measurement. Measurement biases occur when the methods of gathering data or the subsequent interpretation of that data are faulty or consistently different between groups. Within measurement biases, you can have subject biases that occur when a subject's response is influenced by the measurement technique, or a rater bias that occurs when people collecting the data infuse their own interpretation. If we examine subject biases a little bit further, we find 5 different biases. Recall bias is a systematic error due to the differences in accuracy or completeness of the memory or recall of past events or experiences. These are particularly evident in retrospective designs, and we'll see why when we talk about risk and prognosis. Testing bias is a systematic error that can happen when experience with a test may influence the subsequent performance on the test. It's the practice makes perfect phenomenon. Generally, these are related to psychomotor phenomenon where you can get better with practice very quickly. A placebo bias occurs when an outcome is attributable to the expectation that the regimen they're following in the study will have an effect, and it works through the power of suggestion. A Hawthorne effect, which is similar to the placebo except in the fact that it happens when subjects know that they're being watched or part of a study, and that influences their performance. So they're not believing in the thing that they're given, but they have a fear of being watched, and so they act differently. And finally, a desirability bias, which is when a subject responds in a specific way to please the tester that may not be true for them in typical circumstances. There are two possible rater biases, and those include reporting bias, which is when the knowledge of a subject's group allocation or the hypothesis under study influences the decision of scoring that the rater makes on borderline cases. And differential effort bias is when the knowledge of a subject's group or allocation results in a change in effort that the rater makes in collecting the data. So this could be present both within hard data, in terms of like a score on a measure, or soft data from what they gather from interviews. Finally, errors that threaten internal validity from the study can come from poor measurement tools as well. If the tool you're using to measure something isn't a good measure, then the data won't be good either. So what makes a good measurement tool? Well, whatever instrument you choose, it needs to be reliable. Reliability refers to consistency, reproducibility, or repeatability of measurements. Reliability is the degree to which repeated measurements of the same thing will agree. And again, there's multiple forms. You can have intra-tester or intra-rater reliability, which is the stability of a measurement within a single rater, or the consistency or equivalence of measurements when one person makes repeated measurements separated in time. You can have inter or inter-rater, inter-tester, which is the stability of the measurements made between multiple raters on the consistency or an equivalence of measurements when more than one person takes those measurements. Or you can have test-retest reliability, which is the stability of the measurement over time when you don't expect change to occur. It could be the same or different raters making the measurement. The key is that you're measuring a stable phenomenon and you're not expecting it to change. Parallel forms reliability is the consistency or agreement of measurements obtained from different or alternate forms of a test. It indicates whether measurements obtained with different forms can be used interchangeably. So if I give you a test on green paper versus a test on white paper, do they perform the same? Finally, internal consistency is the extent to which items or elements that contribute to a measurement tool reflect the same basic underlying construct or phenomenon, and that's established by determining that the scores on items within a scale or measure are highly related to each other or highly correlated. So is reliability enough on its own? Not really. Just because something is reliable doesn't mean you're actually measuring what you think you're measuring, and that's where validity comes in. A measurement instrument must be proven to measure what you think it's measuring, and that's what validity is. Again, there are multiple forms of validity, including content validity, which deals with the extent to which a measurement tool is judged to reflect all of the meaningful elements of a dimension or concept, and nothing unrelated or extraneous. So content validity typically starts with a literature review and then moves to a panel of experts who try to achieve some sort of consensus about the content area being fully represented. Construct validity is a conceptual or theoretical basis for using a measurement tool in order to make an interpretation. So evidence of this is documented by constructing and testing logical arguments based on theoretical or research evidence. This can be done by determining the strength of relationships between two measures that are thought to be positively or negatively associated with each other, but they wouldn't necessarily be the exact same thing. Criterion-based validity is established when you have a correctness or an interpretation that you can call a gold standard. And so you're really testing it to say you already know something is measuring this construct of interest, and so you're testing it to see if it's exactly the same or very close to that gold standard. And you can do that in two ways. So you can establish criterion-based concurrent validity, which involves assessing the agreement of a measure with another measure that's already been validated or considered to be a gold standard, where both measurements are taken at the same time. Or you can establish criterion-based predictive validity, involving assessing how well the measure predicts some future outcome, and therefore the measurements can't happen at the same time. With both reliability and validity, measures of certain types of validity and reliability are more important depending on the research study design you use and the purpose of the measurement tool. So that'll come a little bit later.